Good morning, class. Good morning, sir. So at this point in our lives, we're busy with Euclidean geometry. Also, at this point, we have completed the first 4 exercises. Now we are 9.4 now. Okay, so with regards to the homework, was there any problems? Yes. Okay. So what I'm going to do is I'm going to do the odd numbers, and then we can see what the problems are still other than that. Is that okay? So you can also get a feel of what is required for when you answer the question. Okay. And you can just ask whatever you're not sure about as well. If it comes to the end of it and we haven't touched on the problem that you had, or you can't still pick up your issue, you let me know at the end, okay? Exercise 9.4, and this is on page 293. All right. We see this on page? Okay. So here we are told that given chord AC and BD intersect at E. So we are told that BC is parallel to AD. If BC is parallel to AD, what do we know? Alternate angles are equal. That's 29, and that should be 29 as well. The question says prove that AE is equal to ED. So under what condition will that be equal? It will be equal if the base angles are equal, not so. So if we can prove that A is 29, we've done the job. Not so. But A is 29. Why is A 29? Angles in the same segment. There's your bow tie. So there the job is done. Not so? But now, the layout is of utmost importance. Okay? Let's pull this over here. So RTP, you're required to prove that AE is equal to ED. Don't you write that down in your exam. Or open up with it, don't. Okay? You go straight into what you got. So we're going to say that angle D is, what number is this? Number 3, no? Angle D is 29. Why is angle D 29 degrees? It is alternate angles, not so? With BC being parallel to AD. You can't leave the set of parallel lines out. You must write it in. Unless there's no letters on the vertices, then you can leave it out. Okay? But if there's a name for your line, you must give the lines at the parallel. Otherwise, you lose them all. Okay? We say that angle A is also 29. Why is angle A 29? Angles in same segment. And it's coming from arc CD. So now we state the obvious. We say since angle A is equal to angle D, which is equal to 29. Therefore, AE is equal to ED. Why? Because it's sides opposite equal lengths. Something like this is worth 2, 3, 4 marks. Okay, could even be 5. But I'll just show you how easy it is to attain these marks. Okay. To get out. Number 5. In number 5, we're given that A, B, C, and D are 4 points in circumference of the circle. AB is equal to AD. If AB is equal to AD, what do we know? We know that angle B is also 75. Why is angle B 75? Sorry? Angles opposite equal sides. Then they want you to prove that angle C is equal to angle D1. But D1 is 75. So if we can prove that C is 75, we've done the job. Not so? But D is 75. Sorry, C is 75. Why is C 75? Angles in the same segment. There's your bow tie. Whoops. That is not the bow tie. There we go. You see that, people? And it's coming from arc AD. Now it's just a matter of writing it neatly out. So you'll start off with B being 75. Why is B 75? Angles opposite equal sides. Then we see that angle C is equal to 75. Okay? So it's angles in the same segment. And it's coming from arc AD. You don't have to write it. Okay? So therefore, angle C is equal to angle D1, which is equal to 75. 3 marks. Yes?
Say you choose to write arc and one label and you have to write AD, but you write AB.
You write here BA.
No, say for example you choose to write the arc.
Arc, yes. And you wrote?
And you write, now you write, I'm sorry.
You wrote AB.
The exam AB, we supposed to write AB.
No, you won't lose them.
You want to know?
No. We're nice people, what? We don't want to penalize you unnecessarily. And that's, at least that's the only mistake you made in your exam. Even then we won't penalize. But try, let's see what happens in next. That's why you take a chance. Alright, number 7. In number 7 we are told that A, B, C and D are 4 points of circumference of the circle. C1 is 40. C1 is 40. B1 is 50. Prove that BD is a diameter of the circle. So BD, so the question you should be asking yourselves. If BD was a diameter, what could you have concluded? Angle C is 90. Or angle A is 90. A1 and 2 is 90. One of the two. So to prove that BD is a diameter, we need to state that angle C1 and 2 is 90. We know that C1 is 40, but C2 will be 50. Why is C2 50? Angles in the same segment. Can you see that? So automatically it will add up to 90. Therefore that would be a diameter. Not so? You guys understand? Right. Let's write this out neatly. So firstly we're going to say that C2 is 50 degrees. Why is that 50 degrees? Angles in the same segment. And it's coming from arc AD. So now we can say this is 90, not so? So we say, since we state the obvious, BCD, since this angle here is equal to 90 degrees by calculation, therefore BD is a diameter. Why? Chord subtends easy. No? 4 marks or 3 marks. Can you believe geometry is so easy? No, you can't believe it. Believe it or not. Okay. Verstaan julle? Right. Let's carry on. Let's carry on. Is this getting sweeter and sweeter, no? Okay. Question 9. A, B, C, D and E are points of the circumference of the circle. I told you I'm going to tell you that over and over and over. It's points of the circumference of the circle. Then we are told that E, B and CA intersect at F. B, D and CA intersect at G. AB is equal to BC. AB is equal to BC. So if AB is equal to BC, what do we know? Angle A is 63 degrees. Not so. Why? Angles opposite equal sides. Then we are told that C1 is equal to 12 degrees. C1 is 12, C2 is 63. So together this makes an angle of 75. Prove that angle D is equal to angle A plus B1. So we must prove that angle D is equal to A plus B1. Okay. Well, what is angle D also equal to? Why are you putting the pencil like this? Are you okay? You are making shapes with the pencil in your eyes? Or no. Okay. I never know. Maybe You know, see, better theorems with pencils between the eyes. But you okay? You understanding this? Nice. Would you like to do with someone? So angle D, people, what's angle D also equal to? 75. Why is D 75? Angles in the same segment. Why you say that if you are bored with this work and you know it all? So that is 75 degrees. So if I can prove that angle A plus angle B1 is 75, I've done the job. Not so? But angle A is 63, we know that already. Now angle B1. Angle B1 is equal to what? How do you get that? Angles in the same segment. You see B1? Subtended angle. See, can you see that, people? So this is also 12 degrees here. So 73 plus 12 is 75. Not so? There we've done the job. Easy. Alright, we're going to use red for the first one. Okay. So we're saying A. So we're saying that angle D is 75 degrees. Why is angle D 75 degrees? Angles in the same segment. And it's coming from arc. Arc? Arc what, people? CB. But if you don't write the arc, it's fine. Eh? CB. EB. Yes, EB. Thank you. Did we say that angle A? So that is 75 on that side. No? Angle A is equal to 63 degrees. Why is angle A 63 degrees? Angles opposite equal sides. And this is your equal sides. Did we say that angle B1 is equal to 12 degrees? Why is it 12 degrees? Angles in same segment. And it's coming from arc AE. So therefore, angle D is equal to angle A plus angle B, which is equal to 75 degrees. 2, 4, 6, almost 6 marks, 5 marks, something like it. Some would give 3 or 4. I will give you probably 4, yeah, 4. Okay? Easy. No? Nice. Then it asks you in B to prove that F2 is equal to angle D. Well, what is angle D? Angle D? 75. So if I can prove F2 is 75, the job is done. Not so? We will investigate. And hang on. There's F2. Well, what is F2 equal to? 75. Why? Exterior angle of triangle. Here's your triangle. And F2 is your exterior angle. So we say, okay. So F2 is equal to 63 plus 12, which is 75 degrees. That is exterior angle of triangle. Dot, dot, dot. And it's triangle AFB. Can you see that? Or I could have said straight, F2 is 75. So therefore, angle D is equal to angle, therefore angle D is equal to angle F2, which is equal to 75. Okay? That was number 9. Number 11 is there 13 as well? No? We are told that two circles intersect at A and B. Then we are told that angle, double chords, no? That means you say that's a chord in the one circle and a chord in the other circle. Which basically means it is straight lines. Okay. Then we are told that angle A2 is 65.7 and angle B1 is 31 degrees. They want you to calculate the size of DFB. I'm going to move this over. These two circles are fairly large. I just want to. Here we go. They want you to work out angle DFB. So in other words, they want you to calculate this angle here. Okay. Right. So where do we start? We start with what we have. Okay, which is these angles here. Okay. So what can I say from the beginning? What can we say? Let's not concentrate on that yet. Which other angles is equal to 31? A1. A1 is equal to 31. What number is this, people? Number 13, eh? 11. Right. So that is 31. Why is that 31 degrees? Angles in the same segment. And it's coming from arc C. Right. Now what other angle can be labeled at this point? Sorry? A3. Why? Angles on a straight line. Nice. So A3 is equal to what? 180 minus 31 minus 67, which gives an angle of? Sorry? 82. Hello? Hello? Yes? Good, I'm busy, me. I'm in a class. Yes. Okay. Okay, so that is 82. Sorry about that. The straight line. Okay. So that's 82 degrees. Now what? Sorry? A2. A4. A4 is equal to what? 31 degrees. Why? Vertically opposite. A4 is equal to 31. Now what? P4? B4. B4 is equal to 31. Why? Angles in the same segment. Nice. Angle in same segment. And it's coming from arc DF. Okay. Then D2. D2 is equal to 82. Why? Angles in the same segment. And it's coming from arc BF. Okay? Do we have enough information to calculate DFB now? Yes? So angle DFB plus 31 plus 82 equals 180. Why? Interior angles of a triangle. sum of triangles, and it's triangle DBF. So DFB, angle DFB is going to be 180 minus 82, which is 96. No, 98. It's 67. Just check. Yes, 67. Okay. Yes? Number 10. Any sums other than number 10? I have a lesson tomorrow, no? For those of you who are interested. That's your time slot is tomorrow from 3 till 4. Number 10 and 12. In number 10, we are told given A, B and C, they are two equal chords. So if these are equal chords, what do we know? Angle F is equal to angle E. Why? Equal chords subtends equal angles at the circumference. Okay. Then we are told that O is the center of the circle, COD is 58. So angle at center is twice angle at circumference. So you don't need anything. It's fine. So you understand. So I don't have to do it. I like when you ask questions. You can just stop in the middle of the sum. Number 12. Who asked number 12? Yes. Good enough. Why isn't it not a... I'm joking. Okay. In number 12, it says given A, B, C and D are points on circumference of the circle. Then we are told that B, D and AC intersect at P, C, B produce to E, which means to say extended to E. Prove that B1 is equal to P2 plus angle D. People never would go straight into that. So what is B1 equal to? What is angle B1 equal to? Yes? P1, yes? Plus angle C. Why? It's your exterior angle of triangle. Dot, dot, dot. And it's triangle BPC. Okay. But that's not what they wanted. However, we know that P1 is equal to angle P2. So we know that P1 is equal to angle P2. Why? Vertically opposite. Okay. Then we know that angle C equals angle D. Why? Angled in the same segment. And it's coming from arc BA. Not so? So now you see that P1 is actually P2 and angle C is actually D. So in conclusion, therefore, angle B is equal to P2 plus angle D. And that's what they want. Okay? Sonia. Right, you're heading for today. You almost We're busy with cyclic quadrilaterals. Cyclic quadrilaterals. Cyclic quadrilaterals. We're just going to run through this definition quickly. What page is this on? 296. Okay, so on page 296 we are introduced to cyclic quadrilaterals. So you know what a quadrilateral is? No? It's a four-sided figure made up of edges, no? Sides or lines. So cyclic is to do with a circle. So cyclic quadrilateral is a quadrilateral, a four-sided figure that fits into a circle, where the 4 points or the 4 vertices touches the circumference of the circle. Okay. So here we are now defining what a cyclic quadrilateral is. So we said a quadrilateral is said to be cyclic if all 4 of its vertices, the vertices are these points here, all 4 of its vertices lies in the circumference of the circle. Okay, you can write this down at home as part of your homework. I'm sure we're not going to get through a lot today. So you can write this down for home. Okay. And you can read through it and all of those things. The second bullet says, 4 or more points are said to be concyclic if a circle can be drawn to pass through these points. So is every quadrilateral concyclic? Every quadrilateral. So if you look at the four-sided figure, 1, 2, 3, 1, 2, 3, 4. Could that be concyclic? Or if it goes in, 1, 2, 3, 4. Is that concyclic? Can you draw a circle through here? All through 4 points? No. You're shorting that point. So is every quadrilateral concyclic? No. Not every quadrilateral a circle can be drawn through its vertices. Okay? It's only certain quadrilaterals where that can happen. Okay? So read that bullet again, that bullet point. If 4 or more points are said to be concyclic, if a circle can be drawn passing through those points. Number 4, the third bullet, sorry. A, B, C, D is a cyclic quadrilateral since the vertices A, B, C and D lies the circumference of the circle. As you can see here, A, B, C and D are lying on the circumference of the circle, therefore it is a cyclic quadrilateral. The fourth bullet, if AB is produced to E, which means to say it's extended. If AB is produced to E, then angle B2, this angle here, B2 is said to be an exterior angle. Exterior means to say the outside angle. It's an exterior angle of a cyclic quadrilateral. It's the outside angle of the cyclic quad. Quadrilateral, quad is the same thing. And then they tell you, remember, that supplementary angles are angles that adds up to 180 degrees. Those are what we call supplementary angles then. Okay. Any confusion there? Right. So now we're going to do the proof of Theorem 5a. Proof of Theorem 5a. It is a theorem that needs to be learned for the examination. Again, in the comment section for description. Yes, description. I'll post the post, yes. Let's get the terminology right here. I'll post the link to the theorems of all the cyclic quadrilateral theorems that is needed for grade 11 and 12. Okay, you'll see the last 2 theorems in that video that is posted in the description below is your grade 12 proof. Okay, so don't learn that yet. It's only for grade 12. Why are you laughing? I'm trying hard to get your terminology right. Yeah. I'm trying. So now you guys try and get full marks, no? What? Amin. Asking too much of you. Right, Igatos. So, Theorem 5a, write this down. Theorem 5a. The opposite angles of a cyclic quadrilateral are supplementary. That is the theorem in words. Okay. In woorde. Woorde, né? What's the words in Kosa? Magama. Amangama. Amangama. Amagama. Okay. Amagama. Okay, so we are given a circle. So we're given a circle. Given a circle with center O. Okay, so you've got the quad here. Draw that. Okay. So given circle center O with cyclic quad A, B, C, D. Okay. And here I see some of you thought your protractor is gone to waste. You're using your compass at least for once. Okay. So we are required to prove that angle A plus angle C is equal to 180 degrees. So where do we start? As we always start. With A? Nice. So we start with the construction. Construction. So we're going to construct DO and OB. Radii, OD and OB. Forming angle O1 and O2. So, what can be said now? We can say that angle O1, sorry, O2 is equal to, angle O2 is equal to what? Angle O2 is equal to what, people? Twice angle A. Why? Angle at center is equal to 2 times angle at circumference. Okay. Angle at center is twice angle at circumference. Alright. What can we say about O1? Angle O1. Angle O1 is double angle C. Why? Angle at center is equal to 2 times angle at circumference. Not so? Yes?
Can you say, can you find O1
Yes, O1 is going to be what? 360 minus O2. Yeah. But what do we know? So exactly your understanding of that there is going to come into play. We know that angle O1 plus angle O2 is equal to 360 degrees. Why? It's a revolution. Or angles around a point. Not so? Those angles adds up to 360, or 1 and 2. Not so? You all agree with that? So, I actually had to do this first. Let's bring this down. What is O1, angle O1 plus O2 also equal to? O1 is 2C, O2 is 2A. Not so? If O2 is 2A and O1 is 2C, then O1 plus O2 has to be 2C plus 2A. Not so? Right. Now this comes into play. We say that O1 plus O2 is equal to 360 degrees. Why? It's a revolution. So what we now do is we replace O1 and O2 with a 360. So in other words, angle 2C plus angle 2A is equal to 360. So I divide now by 2. Therefore, angle A plus angle C is equal to 180 degrees. Or angle C plus angle A is equal to 180 degrees. Okay. And if we use this theorem, the reason is opposite angles of cyclic quad supplementary. Opposite angles of a cyclic quad supplementary. Okay. Now this is worth 4 marks, 4 or 5 marks in the exam. Okay. I said opposite angle supplementary. Leave the supplementary part out. Put it here out of the way. To say opposite angles of cyclic quad. Let's realize now when it comes to the converse, we use that word supplementary. Okay. So that you don't get confused, man, when to use what. Okay. So let's look at the converse. The converse is not a theorem that needs to be proven. As we said, converse is the reverse, no? So write this down, that wording there. Theorem 5b, which is the theorem of the converse of theorem 5a. If opposite angles of a quadrilateral are supplementary. So you're not supposed to be seeing the circle. Okay? If opposite angles of a quadrilateral is supplementary, what does that mean? That means to say if you've got a quad and these opposite angles adds up to 180, or if this is 50 and this is 130, if those opposite angles are supplementary, they do add up to 180, then PQRS is a cyclic quad. Why? So opposite angles are supplementary. Okay. So to see what they wrote here, if opposite angles of a quadrilateral are supplementary, then the quadrilateral is cyclic, which means to say a circle can go through the vertices of that quadrilateral. Okay. They're just clarifying here. If angle A plus angle C is 180, or angle B plus angle D is 180, then ABCD is a cyclic quadrilateral. That is, the circle can be drawn passing through ABCD. Reason for using this theorem is opposite angles supplementary. Okay. People, for homework, I want you guys to look at exercise 9.4. Okay. Especially if you had issues with it. Okay. Redo it so that you have mastered that at least as we go into the next theorem. It's application. Okay. People, enjoy the rest of your day.